This lesson we are looking at applications of quadratic equations, meaning word problems that are going to result in a quadratic equation. Let's just review. We have looked at consecutive integers before. Remember, integers are only negative and positive whole numbers. They do not include decimals or fractions. If we have two consecutive integers, we have x and then x plus 1. If we needed another one, we would do x plus 2, x plus 3. Remember, consecutive means in a row. They also could be negative. Odd integers are set up as x, x plus 2, x plus 4, and as we talked about in a previous lesson, I know that the odd ones look weird because you're adding 2, 4, 6, but 1 plus 2 is 3. 1 plus 4 is 5. So that's why you use the plus 2 plus 4 for the odd. And you do the same thing for the even numbers because they are spaced out the same way. You would have to add 2 to get to the next one, 4, and so forth. So consecutive integers, odd, even. So just like we did on previous word problems, I'm going to ask you to define a variable, to write an equation, solve the equation, and let's make sure we answer the question. So the first few deal with those consecutive integers. It says two consecutive integers whose product, that might be a new word, product means we're going to multiply things together. Right, so find two consecutive integers whose product is 45 more than 3 times the larger integer. Wow. So let's start out with two consecutive integers. So I'm going to let the first one be x, and the second one is x plus just 1. Doesn't say even or odd. Define that variable. I need to see that on your paper. Now we're going to write that equation. Find two consecutive integers whose product, that means I'm going to multiply those two things together. Is means equals. 45 more than, that means I'm going to add 45 to 3 times the larger integer. Well, which one's the larger one? Well, yeah, x plus 1. So 3 times the larger one plus 45. Two consecutive integers whose product is 45 more than 3 times the larger integer. Translating those words to mathematical symbols. So I've written an equation. Now I need to solve the equation. And remember, these are going to lead to quadratics, meaning we're going to have to factor. So let's multiply those out. We're going to collect like terms. That's 48. And now if it's quadratic, I need to set it equal to 0. So I like to keep my x squared positive. So I'm going to subtract 3x from both sides. Still need to set it equal to 0. So I'm going to subtract 48. Now I need to factor. This is where we get to practice those trinomials. Leading coefficient of 1 makes it a little bit easier. So what multiplies to get negative 48 adds to get negative 2. Negative 8 and positive 6. Then we set both of those equal to 0 and we solve for x. Are we done? No. It says to find two consecutive integers. Well, I have found two numbers, but they are not consecutive. 8 is not followed by negative 6, or negative 6 is not followed by 8. This is both answers for x. That means I have two answers for x. I need to know what x plus 1 is. Well, if x is 8 plus 1 is 9, that's two consecutive integers. But wait, I also have x is negative 6 plus 1 is negative 5. That is another set of answers. And yes, you need both. Going on to number 2. Find two consecutive odd integers whose product is, and I'm going to stop. So same type of setup. The first one is x, but this time the second one, since it says odd, I need x plus 2. Right? Whose product? That means I'm going to multiply them together. So find two consecutive odd integers whose product is 4 less than. That means I'm going to subtract 4 from what? 3 times the larger integer again. So 3 times x plus 2. 4 less than means I need to subtract 4 from the 3 times the larger integer. So now I need to multiply, collect like terms, and again you must set them equal to 0 before you start factoring. So I'm going to subtract 3x from both sides. I'm going to subtract the 2 from both sides. And again, I have a leading coefficient of 1, so what multiplies to get negative 2 and adds to get negative 1. Setting both factors equal to 0 and solving for x. Not done. I need to find two consecutive odd integers. I've only found x. Now I need x plus 2. So if x is 2 plus 2 is 4. Now wait a minute. I was supposed to find odd integers. 2 and 4 are not odd. I don't think I've made any mistakes. I just have to throw those out because those are not odd. I guess I should have started out with the 2 not being the odd. But negative 1 is odd, and if I add 2 to negative 1, negative 1 plus 2 is positive 1. Those would be consecutive odd integers. Same type of thing. This time we've got two consecutive even integers whose product is, and I'm going to stop there. So my first one is x. My second one is x plus 2 again because even. Even and odd, same. So whose product is. Now I can keep going. 10 less than, so I know I'm going to subtract 10. 5 times their sum. Wow. So 5 times something. Their sum. What does that mean? I need to add those together. So I need a little more room. So 5 times their sum. I'm going to, let's see, collect like terms inside of here. So 5 times their sum, 10 less than 5 times their sum. I think I've got it set up right. So let's start distributing. When I start collecting like terms, I've got 10 minus 10. I believe that's 0. So I need to subtract 10x from both sides because it's quadratic. I need to have it set equal to 0 before I start factoring. I don't have a trinomial. I have a binomial. What type of factoring? GCF. So I set both equal to 0 and solve. What am I looking for? Even. Well, x equals 0, that's even, and x plus 2 is 2. So that's one set of answers. And 8 plus 2 is 10. Those are also consecutive even ones, even integers. So that's another set of answers.